Hey everybody, let's get right into it. I'm going to go over the answers to last week's practice problems and maybe mention a couple of things and do another assignment. People did pretty good. It was weird though. Some of the answers, like for example, for number 4, people were giving me an answer. Well, I don't know, they were giving me the mass of something. That wasn't even part of the question. I don't know, maybe Quizlet is messed up. Number 1, I did number 1. Number 2, all right, sorry. Number 2, let me adjust this. 1.45. Does this show up? Yeah. 1.45 times 10 to the negative 17th power moles. And you're asked to convert that into atoms. That's moles of sodium ions. I'm sorry, moles of arsenic atoms. So how many atoms would that be? Well, I wanted to see the conversion factor, 1 mole of arsenic and 6.022 times 10 to the 23rd, not negative 23rd. That's positive 23rd. It's a big difference when you put a negative there. And that would be atoms. And of course, the moles drop out. This becomes a multiplication problem. And there are people that weren't able to do that. But when you multiply this up and when you multiply exponents, you add them, which in effect you take 23 and subtract 17, and that would be 10 to the 6th power, right? And this times that is 8.7319. And that's an answer. Of course, I rounded it to the proper number of significant figures because there's 3 here, 3 significant figures here, 4 there, rounded to 3. And the answer would be 8.73 times 10 to the 6th power. Did you get that? Some people did. Some people did. Let's just do number 4. I'm not going to do number 3. And number 4, you're given 5.9 moles of sodium hydroxide, which is an ionic compound, right? Put the polyatomic ion in it. So how many formula units would that be? Because that's how we call that. We refer to these as formula units. And here we have 1 mole. This is 5.9 moles. 6.022 times 10 to the 23rd formula units. You know, practice makes perfect with this. You would have gotten a lot of practice, but you didn't get to practice. But anyway, 23 formula units. This drops out. This becomes a multiplication problem. And after you multiply this out, you get 35.5298 times 10 to the 23rd power, which we round off to 2 significant figures. So that would be, well, wait, this is a 5, this is an odd number. We round it to 36. Remember that? And that's 36 times 10 to the 23rd. But we want to move the decimal over 1 to make this 3.6. And so that means we have to raise that by a power of 10. And that's the answer. And that's it. That's simple. It's not in grams. People were giving me answers like, I don't know, it was like 200 some grams or 236 grams. Where does it ask for the mass of this? There's no mass here. I don't know where that came from. And, a lot of people didn't show me work. Whatever. So anyway, that's it. I wanted to, we're going to do a different thing now today. Today, instead of giving you moles and asking you to convert into atoms or anything, we're going to give you the atoms, the formula units, the molecules, and convert it into moles. And really what you're doing is, because you're going in the opposite direction, you're reversing it, you reverse the conversion factor. So instead of going from grams to kilograms, we're going from kilograms to grams. And if you remember, we just inverted the conversion factor. But before I do that, I just wanted to mention something. You know, a mole is a number. And we use the mole a lot in chemistry. Like, for example, if I have 1 mole of water molecules, that would be 6.022 times 10 to the 23rd water molecules, right? That would be 1 mole of molecules, right? But how many moles of hydrogen atoms would that be? How many moles of hydrogen atoms would be in 1 mole of water molecules? I'll wait for your answer. Do you think you know? How many moles of hydrogen atoms? That's the question. The answer is 2. Did you get that? For every 1 mole of molecules, there's 2 moles of hydrogen atoms. Doesn't that make sense? Of course. If I had 1 mole of Oreo cookies, how many moles of chocolate wafers would there be? There'd be 2 moles. For every 1 mole, there's 2 moles. Do you see where a conversion factor would lurk? Like, for every 1 mole of H2O, there are 2 moles of H. Do you see that? We're not going to get to that, but that is where we would have gotten to if there wasn't a virus outbreak. Some of you might take chemistry in the future, so that's a conversion factor. These are the kind of things that we do in chemistry. But anyway, we're going to do some practice problems from the textbook, where instead of, in effect, multiplying, we're dividing. Let me do the first one for you. If you have 5.66 times 10 to the 23rd atoms, that's a lot of atoms, right? 5.66 times 10 to the 23rd atoms. If you have that many atoms of xenon, how many moles is that? How can I convert that into moles? By using our Avogadro's number, 6.022 times 10 to the 23rd, and applying it to this. So let me make room here. So now I want moles to be my answer, but I have to divide out the atoms, and there's 6.022 times 10 to the 23rd atoms. The atoms cancel out. So in effect, what I'm doing is I'm taking this and dividing by that, and that should give me the moles. It will. So how do we do division? 6.022 times 10 to the 23rd. We subtract exponents and we divide just like before. So what's 23 minus 23? Isn't that 0? Which is the same as 1. And what's 5.66 divided by 6.022? Well, it's a little bit less than 1, isn't it? It's 5.66 divided by 6.022, and that's 0.939887, which we will round off to 3 significant figures, and that would be 0.9. Well, how do we do that? Look at this. This 8 rounds that up to a 10, which rounds that up to a 4, which that stays the same, but how can we have three significant figures? 9.40. The 0 is significant because it's to the right of the decimal and at the end of a number, and times 10 to the 0, and that's 1. So I could just say 0.940, or if I wanted to write it in scientific notation, I could say 9.40 times 10 to the negative first power moles. What do you think of that? That's the first practice problem on page 229. That was the first practice problem. I'd like you to try to do. Now, there's a lot for number 5, and they're tricky. See if you can get any of those. So I'd like you to do 2. Show me your work, please. I'd like you to do practice problem number 2, practice problem 3, and you can skip 4. And 5, goes from A, B, C, D, E, F, and G. Just do A and B, okay? That's not so bad. That's not bad at all. Please show me your work. And if you're asked to give me the moles of something, give me the moles of something, not the grams, not the mass, okay? Or whatever. Read the question before you give me an answer. I'm just saying. All right, so anyway, okay? So if anybody has any questions about anything, I've been trying to make myself available every day on Google Meet. So, okay, signing off.